map which takes into account the pollutants distribution you need for interpolation. So the small sized systems can provide a promising approach. For example, thanks to their installation in public vehicles such as buses or service vehicles, but also private cars. And another important issue is related to the data exchange and harvesting, which can be performed by means of a specific infrastructure called smart road. So there are some open issues related to the interpolation algorithm, but also related to the data fusion of those data coming from different sources and sensors. So starting from the smart road concept, we have a definition provided generally by Wikipedia, for which the smart road is an ensemble of technologies incorporated into roads for autonomous vehicles, traffic lights, street lighting, for monitoring road condition, traffic levels, and the speed of vehicles. In our vision, it is an intelligent two-way means to connect the vehicles to a smart city platform in order to exchange data and alarms so that we can have a local awareness transferred to a general platform and transformed in a global awareness, which on the other side can provide specific information to the vehicles on the road. This is the basic paradigm of the smart road. So, if a vehicle which transit on the smart road is able to collect data, for instance, related to pollutants or to other physical atmospheric parameters, then it can transfer this information to the smart city platform. In particular, the device tested in this work is able to collect the 7 pollutants listed in the table that you can see in the right part of this slide. In addition, the device is equipped with physical atmospheric sensor for the acquisition of parameters such as temperature, humidity, and so on, a GPS positioning system, and a Wi-Fi device to connect with other elements of the smart road. And these are the size and dimension data about and the power data about the sensor. We have carried out some experimental campaigns in Rome, in the northeastern part of Rome, where is located fixed system station which continues to acquire information about and data about pollutants. So we have performed 2 different acquisitions. In order to simulate a multi-car path inside within the test area, and to simulate also the path of a public bus, a specific line of the public bus which serves this part of Rome. And in order to acquire different pollutants, and in this case, in this slide, you can see the information about the PM10 concentration in a normal traffic condition in a typical morning situation of Rome. So, once those data were acquired, they were transferred to the Smart City platform, a GIS-based decision support system, in order to perform an interpolation and test a communication channel between the sensor deployed on the road and the central Smart City platform. So that when this experimental phase will be closed, we have an operational system in which the graphical visual interface will be able to show a map such as that one that you can see in this figure, in which we have interpolated by means of regularized spline method the PM10 acquisition showed in the previous slide. So some issues are emerged from this work, which are open issues, of course, and also elements representing the future developments of our work. First of all, there is a key point that many sample points are more advantageous versus few sample points, especially if you can acquire them with many low-cost systems. Of course, you have to deal with issues related to calibration and reliability of the sources. If you manage sensors deployed on public vehicles such as buses, you can plan, for instance, a regular maintenance and calibration of the sensors. If you rely on sensors owned by private citizens and installed on private cars, of course, you have to deal with reliability and calibration issues that you cannot properly control. For this reason, in the next developments, we will work on the data modeling in order to take into account those uncertainties, and also other factors, for instance, related to the airflow, because the acquisition is performed by means a vehicle moving on the road with a specific typical speed. And the other issue is related to the spatio-temporal data fusion algorithms, for which we will study a proper and more effective solution in order to improve the results. I am to the last slide. I am pleased to close with a message from Sergio, who wrote a sort of a Fortin cookie aphorism: a large number of experimental points, even if far from optimal, is a wealth not to be disregarded. So thank you for your attention, and this is all.
Thank you.
Elena, I have a question, but we don't sound you. We don't sound you.
I have a question for Dr. And do you have any information regarding the quality of the actual data? I mean, did you compare it with estimate some reference value? If so, how about it? What do you think about it?
Maurizio?
So he's probably disconnected from no problem. We will have some question time of the session. So let's proceed to the second presentation of this morning. This is presented by Dr. Domenico Toscano, and the title of the presentation is Physical and Numerical Model of Atmospheric Urban Dispersion of Pollutants. Dr. Toscano is a PhD student from University of Naples Federico II. He's from the Department of Chemical Materials and Production Engineering. And his main research interests that he is developing in his PhD are physical and numerical modeling of atmospheric urban dispersion of pollutants. So, I let the floor to Dr. Domenico Toscano. So please show your presentation.
Okay, thank you, Saverio. Hello, everybody. I share my desktop, my presentation. I present today our work, physical and numerical models of atmospheric urban dispersion of pollutants emitted by cruise ships in Naples ports. This work was carried out from the collaboration of Federico II and the École Centrale de Lyon. So the Naples port is one of the most important ports in Mediterranean area. It is length of about 11 kilometers and formed by a total of 75 berths, divided between terminal for hydrofoils and small ferries, cruise terminals, and ferries and commercial vessels. Therefore, the port serves 614 to 6 millions of passengers, about 52,000 vessels, and an annual traffic of 514 to 520 foot equivalent units. Different studies were conducted to estimate the contribution of the ship emissions on air quality in Naples. For example, Murray et al. Have been estimated the cruise ship contribution on air quality in a urban area with the CalPAF model. So the results of this study is the maximum contribution of cruise ship emissions on pollutant concentration levels to 1 hour peak is about 86%. Dispersion models are often used to assess the impact of ship emission. However, a rigorous evaluation procedure must be followed to ensure the quality of the model results. Evaluation procedure that can be performed with wind tunnel experiments. The experiments in this study were performed in the atmospheric wind tunnel of the Laboratory of Fluid Transfer and Acoustics at the École Centrale de Lyon in French. This is a recirculating wind tunnel with a working section measuring 14 meters long, 3.7 meters wide, and about 2 meters high. In wind tunnel was investigated two different parameters. The first, the flow dynamics, and second, the concentration measurements. For the flow dynamics were investigated by hot wire anemometry. The hot wire constant anemometer allowed the simultaneous measurements of two velocity components, and we acquired the transversal and vertical profiles of velocity statistics. And velocity statistics, we recorded 120-second time series with a sampling frequency of 5,000 Hz. For the concentration measurements, we were performed with a fast flame ionization detector with a frequency response of the instrument about 400 Hz, and a mixture of higher ethane was used as a tracer in the experiments. Concentration statistics extracted from each time series include the mean, the standard deviation, the third, and the fourth moments. Sorry for the for the experiments in wind tunnel, we have reproduced an area of about 1.2 square kilometers. This area was reproduced in scale 1 to 500. The measurements were conducted with wind direction blowing from southeast, because this is the most impacting case for the transport of pollutants in the urban area. We also considered the contribution to the urban pollution due to three cruise ships in hotelier phase. A neutrally stratified boundary layer was generated by combining the effect of a grid turbulence and a row of spires placed at the beginning of the test section and the Ragneth element on the floor. This experimental setup reproduces a boundary layer of height 0.8 meters, a Ragneth length of about 2 millimeters, and we have also obtained the mean velocity profiles and the turbulence intensity profiles as reported in this slide. All these parameters measured in wind tunnel was used in input in CalPath and CFD models to reproduce the same condition as the wind tunnel. So for the measurements, the concentration measurements, we choose 37 measurement points. The concentration in this particular case is a function of the height, depth of the boundary layer, Ragneth length, velocity of the ship emissions, the wind velocity at the stack height, and the mass flow rate. So fixed the geometric parameters as height, boundary layer height, and the Ragneth length, the real concentration is a function only of the ratio of exit velocity and the velocity of wind at the date of the source. In terms of the results, the preliminary results, firstly, I compared the concentration of sulfur dioxide at ground levels between the results obtained with wind tunnel experiments and the same obtained with the CalPath simulation. This comparison, as can be observed in these two figures, the level of sulfur dioxide concentration obtained by wind tunnel is measured than the levels obtained with the CalPath model. Another results are the vertical concentration profiles between wind tunnel experiments, CalPath, and CFD simulations in the right of this slide. As can be observed, the agreement with wind tunnel in the black points in these graphs, and the CFD simulation, the line blue in each profiles. And the result is good between CFD and wind tunnel, but the same agreement is not observed when the results of wind tunnel experiments are compared with CalPath simulation. In fact, CalPath generally underestimates sulfur dioxide concentration, as seen also at ground level maps. The preliminary results of our research show how the urban canopy can modify in a significant way the impact of ship emissions emitted during the hoteling phase. The effect of buildings in the urban area is not represented by the building downwash option in CalPath that is able to capture only the flow field modification due to ship itself and to some port structure near to the docks. Preliminary results indicate a good agreement between wind tunnel experiments with the CFD simulation and a tendency of CalPath to underestimate ground level concentration. The use of wind tunnel test or CFD simulation can give important and quantitative information to validate the dispersion models like CalPath, increasing the precision of simulation. Thank you for your attention.
So thank you, Dr. Toscano, for this very, very interesting presentation. And I would like to open the floor for questions. So if there are any questions, please. So
I have a question. Saverio, I have a question for Domenico. What is, Domenico, the added value of using an integrated approach, including physical modeling and simulation modeling, compared to using only one of them, only physical modeling, only simulation modeling? What is the added value of the integrated approach?
Thank you, Grazia, for your question. So the physical models have a computational and realization time measured than numerical models, and present some limitation in terms of the studio dimension and the number of meteorological and hemispheric scenarios. But they have the advantage of allowing results of considerable reliability. In the case of complex problems, as the pollutant in the urban area, could be useful to carry out first a validation of a numerical model with physical model, and then is it possible to extend the analysis to a longer period or to a bigger area.
Okay, thank you. Another question. You said there are preliminary results, preliminary study, but during your study, have you identified possible other developments?
Yes. Based on the preliminary results presented in this work, we are working to extend the study, verifying the effect of the other emissive parameters on the pollutant dispersion, and we extend the measurement, the numerical model to a longer period as 1 years of data, and to our big area in the port of Naples.
Okay, congratulations. It's very interesting, your work.
Thank you very much.
Okay, before going to the next presentation, I would like to make a test with Dr. Esposito in order to understand if the mic is working or not currently. Quick test. Please, Elena. We can hear you very, very faintly. So you have to try to speak more loudly or more closer to the microphone.
And now I test different mic.
Okay, this one is better.
Okay.
But you have to speak a little bit closer.
Okay, thank you.
Thank you.
Your microphone is muted.
Okay, sorry.
Okay.
Let's go to the third presentation of this session, and it's a work carried out cooperatively by ENEA and the University of Naples Federico II. Dr. Nocerino will present this work, and the title is Estimating Air Pollution-Related Solar Insolation Reduction in the Assessment of Commercial and Industrial Rooftop Solar Photovoltaic Potential. So, please, Dr. Nocerino, the floor is yours.
Yes, thank you for your presentation. Good morning to everyone. Okay. Can you see my screen?
Now we are seeing it.
Okay. So good morning to everyone. I will present a study addressing the impact of haze on the estimation of the commercial and industrial rooftop solar PV potential. Air pollution is known to be a serious problem of growing urgency, mainly for its effects of human health. Recently, however, the air pollution effects in other fields, such as the photovoltaic energy generation, have been investigated, and notably, the relation between the reduction of the solar insolation and the PM 2.5 concentration in the air. Air pollution typically includes fine particulate matter, which, suspending in the atmosphere, can affect the passage of light through the lower atmosphere, reducing, consequently, the solar radiation intensity reaching the ground. So, apart from major haze events affect several cities in the eastern Mediterranean, reaching a high PM 2.5 concentration, air pollution is a problem most cities around the world suffer, though at several seriousness levels. So, in our previous work, we have analyzed the correlation between PM 2.5 concentration and the loss in insulation using local long-term field data from a monitored location in Naples. And as a result, we obtained that the amount of solar radiation is exponentially correlated to the PM2.5 concentration, as shown by this equation, in which height 0 represents the insolation at 0 micrograms per cubic meters. Instead, I represents the insolation affected by PM2.5 concentration. So using the derived functional relation, we calculated the amount of insolation Naples would have received without the air particulate pollution within 1 year. And then we estimated that solar insolation reaching the ground is reduced by about 5% due to the annual average PM2.5 concentration. So this derived empirical relation represents itself a result. It enables a way to predict the influence of air fine particulate pollution on the solar energy potential in PV suitable sites as buildings' rooftops. And until 2030, it is expected that EU countries will increase the use of solar PV systems for realizing the 32 target of renewable energy production. Recently, it was estimated that the systems developed at existing buildings could annually cover the 25% of the electricity demand. And in particular, Italy could cover more than 30% of its electricity consumption by developing PV systems at its most advantageous rooftops. So this study focuses on the assessed solar PV potential of C&I buildings' rooftops, taking into account the estimated solar insolation reduction due to air fine particulate pollution. And the objective is create a solar energy potential map of buildings' rooftops at a single building scale and at regional level, using a high-resolution GIS-centric methodology based on LIDAR data, digital surface modeling techniques, and suitability analysis. The applied methodology is based on determining the available suitable rooftop area and on estimating the solar PV potential. More specifically, main steps are, first of all, derive a detailed building model. For second, identify a comprehensive set of suitability factors. And finally, apply advanced solar radiation methodologies. The case study is the industrial area of Aversa Nord in Campania, South Italy. It's one of the greatest regional C&I zones, and it covers a very large area, including around 1,000 factories that operate in textile sector. And so for estimating the available rooftop area, processing LIDAR data, an high-resolution DSM of the C&I built was generated. And assuming that the building rooftop area is equivalent to the related footprint area, the potential rooftop area for solar PV installations is identified by 368 potential buildings. It is known that many factors may lead to the reduction of potential roof area. And these factors for our study, for the present study, were derived from high-resolution DSM of the study area, as well as from literature reviews. And so on the basis of the slope and aspect raster layers derived from DSM and the building footprints layer, the suitable rooftops orientation and slopes were derived by remove the rooftop areas with the slope steeper than 45 degrees and north-facing rooftops. Also, other factors were considered in our study, and these are, for example, the construction restrictions, the service area, or the minimum roof area, or the minimum incoming insulation fixed at 800 kilowatt-hour for square meters for year. The solar radiation is here calculated on the roofs of the buildings using the area solar radiation tool. And once obtained the solar radiation map, the insulation reduction due to the fine particulate in the air has been evaluated using the derived equation. And the map on the left shows that the solar radiation affected by PM 2.5. Instead, the map on the right shows the spatially distributed solar insolation reduction on the study area. And we can note that it is about 5%. Aggregating the solar energy potential data calculated for single usable rooftop of our study area, we found the total amount of solar radiation received per year by usable rooftop area. That is about 393.55 gigawatt hour per year. Then the usable solar radiation is converted to electric power production potential. The amount of power that solar PV panels can produce depends not only by the solar radiation, but also by solar PV panels' efficiency and the installation's performance ratio. So combining these two factors with the solar radiation layer, the rooftop technical PV potential for each suitable rooftop is calculated as shown in this map. And here in this table, we can read the results. For example, the total number of usable rooftops. There is 341, that of course is less than the total number of rooftops processed by ArcGIS Pro. And in the lower part of the table, we can read, for example, the aggregating data of the solar energy potential and the electrical power potential for the study area. In conclusion, we can say that the atmospheric particulate pollution can significantly reduce the solar radiation reaching the ground and the PV systems, affecting their performance. So with the high-resolution spatial analysis, it's possible to estimate the rooftop solar PV potential, taking into account the effects of the air-fine particulate pollution on the solar radiation. And to implement for the future development a more precise rooftop solar energy potential calculation, it could develop a 3D building model, such as a 3D vegetation model. And in addition to this, it could be applied an high-resolution PM 2.5 distribution simulation model for calculating a more precise insolation reduction factor. And finally, it could be extend the 3D factors set and the solar energy potential map at regional level. So thank you for your attention.
Thank you, Martina, for your presentation. And yes, the floor is open for questions. Thank you for being in time. Are there any questions? So if not,
I have a question.
please, grazie.
You have congratulations, Martina. It's very interesting. Your research work. I have a question for you. You have derived an empirical relation for quantifying the effect of air-fine particulate pollution on solar radiation. But how did you use this relation in the calculation process of the rooftop solar PV potential?
Okay, thank you for your question. Well, a continuous set of PM 2.5 distribution on the sea and I built area was generated using the geostatistical ordinary kriging interpolation technique based on the data set of the annual average of PM 2.5 concentration gathered by the regional station network of HARPAC. And then combining the PM 2.5 distribution map and the solar radiation map, an high-resolution solar insolation map affected by the fine particulate was derived for this study area as shown in the presentation. And let me add that though the air pollution levels in our zones are lower than in Delhi and Singapore, considering the reduction of solar radiation due to air-fine particulate pollution can really make the difference between a solar PV installation meets the expected output and one that fails.
Thank you, Dr. Nocerino. I have one more question.
Yes.
for you.
Yes.
If I understood, you used an average annual PM 2.5 concentration level in order to estimate the impact of PM on solar energy production.
Yes.
Well, it's more a comment than a question. Probably, I mean, it should be investigated how the anthropogenic cycle of emission may affect your computation, because of course during the night when the solar panels are not active, the concentration of PM is very low, really low, and this will lower the average concentration, if I understood well. That means that probably the impacts are a little bit higher.
Yes.
And also we have to consider the usual cycle that PM concentration goes during the days, because usually the highest concentration are measured when the solar panel are receiving a fraction of the maximum irradiation, because it's not close to midday. Usually the PM levels goes down because there's more recirculation.
Yes. Yes. Yeah.
It will be
Okay.
interesting to analyze these effects on the actual computation, and we may found that probably the impact is slightly higher than what we have actually computed. By the way,
Yes, thank you for your question. What you said is correct, and of course, it will be very interesting to investigate this case. But for this study, the correlation between the radiation data and PM 2.5, the data were tested, and the result of the test shows that it is statistically reasonable, that the correlation is however a statistically reasonable possibility. So for this study, we're stopping in this point, but of course it could be interesting investigated other possibilities.
okay, thank you. Okay, and last but not least, we have the presentation from Dr. Esposito. The title is Optimal Field Calibration of Multiple IoT Low-Cost Air Quality Monitors, Setup and Results. Dr. Esposito is a researcher from ENEA, Portici Research Center, and her research interest focuses on optimal calibration with artificial intelligence, with embedded artificial intelligence of chemical multi-sensor systems. So I leave the floor to Dr. Esposito and to listen for her interesting presentation.
Thank you, Saverio. In this case, for my microphone problems, I say the first will be the latter. I share my Can you see my screen?
Yes.
Okay.
Please show the presentation, because now we are just seeing your Chrome.
This is now?
We don't see it anymore. You should share the PowerPoint window or the entire screen.
It's okay?
No.
So?
No, we are not seeing at the moment.
Okay.
Okay, now we're seeing it.
So in this presentation, I will talk about a field validation experiment of an IoT system based on air quality multi-sensor devices. Experiment that has been carried out in a mobile mode. That means 4 multi-sensor devices have been co-located with an air quality mobile regulatory analyzer. But I will clarify this during the presentation. Now I want to briefly show the presentation outline. First, I want to explain the motivations of this work and the background in which we are working. Then we will see some details of the validation experiment, the experimental framework, and the calibration methodologies that we have used. And finally, I will show the obtained results and the conclusions. So, what are the motivations? We know that the environmental issues are very important for the citizens, also and especially in this emergency period. And in particular, in the last years, several projects focus on the citizen science. But how can we develop a good air quality-based citizen science project? Different factors are involved. Several aspects have to be considered. For example, start from the main local source of air pollution. Local government and a number of stakeholders are seen as a partner of the project. Then a tool for air quality exposure monitoring, specifically built for the citizen use. The data are gathered and shared among the citizens and all stakeholders. Then the citizen subsets are on continuous relationship with the project partner, especially their local government. And in this point of view, we are working in the, within the Air Heritage Project, an urban innovation action project in which several partners, among them Enea, Portici municipality and others, develop a pervasive monitoring station network in the city of Portici. Through this new pervasive monitoring station network, we will be establish a city air quality measuring and high resolution mapping and remediation design. But what is the experimental setting, the core of this project? In the figure we will see, we can see the IoT system consisting of a network of air quality, low-cost air quality multi-sensor devices, specifically Monica, l'Italian monitoraggio cooperativo della qualità dell'aria. These nodes send raw multi-sensor data to a Raspberry Pi, and the data are stored in a NoSQL database, specifically MongoDB. And the data can be visualized in a web interface. But Monica device is a low-cost multi-sensor device equipped with electrochemical sensor array, specific alpha sensing for class sensor units, targeting several pollutants. In our case, the carbon monoxide, the nitrogen dioxide, ozone, and two environmental variables, relative humidity and temperature. The specific, in this specific deployment, 4 Monica nodes have been co-located starting on February 2020, together with a mobile ARPAC reference station. ARPAC is a Campania Regional Agency for Environmental Protection, and the data recorded in this field campaign are reported in the table. For each node in the table, we can see the acquired data in our hourly averaged and in minutes. And for a fast and graphical visualization, we can observe the picture below the table, in which we can quickly identify the data losses. Specifically, green boxes represents acquired data, while the red boxes indicate data losses. We can observe that one of the devices has lost more data than the others due, for example, to connectivity problem. In the figure on the right, we can see the NO2 concentration behavior, the target gas concentration provided by ARPAC station, and it is possible to observe the specific events highlighted by the ellipses. we can see a significant decrease in average hourly NO2 concentration due to the influence of winds with different intensity and direction. This can influence the performances because we have a very low concentration value, very close to the limit of detection. These data have been calibrated using two different approaches, one linear and one non-linear. Specifically, a multiple linear regression model and shell of neural network models. The input matrix of these two models consisting of different features. In this case, we see double E and high E concentration that are respectively the working electrode and the auxiliary electrode of the sensor. In this case, we estimate the NO2 concentration, and then the input are the raw signals of these sensors. And then we consider the twin electrode relative to main interference. In the case of NO2 concentration estimation, we take into account the O3 as interferent and then the environmental parameters readings. The obtained results are reported in this table. The two calibration algorithms have been compared using different training lengths, while keeping 1 week of data for shallow neural network regularization purposes, and the remaining data for testing purposes. So to simulate a real condition where nodes will be operated after the calibration phase. And in this table, we can see 4 experiments. In particular, the first experiments and the first line of the table has been performed taking into account the first week of data for training the set and the second week for the parameters optimization. Then we have enlarged the training set by adding data up to 1 month, and the next week for the validation. What can we observe? First, the results show that the device's performances are consistent, except one that works worse than the others. And we can observe that enlarging the training set does not provide significant improvements with respect to choice 1 week for the training.
Just 1 minute left.
Sorry?
Just 1 minute left.
Okay, thank you. In the left figure, we can see NO2 concentration estimation computed for each node along the entire prolongation period versus the target gas concentration line. We can see the differences among the 4 sensor performances, in particular when considering the low true concentration of the target pollutant. In the right figure, fitting these points, we observe in a fast way the differences among these nodes. For example, this allows us to detect a malfunctioning device in this case. And in conclusion, we have performed a mid-term validation experiment in which we have compared the air quality multi-sensor devices performances. In particular, we have observed that for an optimal calibration, in this case, enlarging the training set will not achieving significant improvement in the calibration performances, and in particular, collocating several devices, we can see that the performances of the devices are consistent. Thanks for your attention.
So let us thank Dr. Esposito for this nice presentation. And unfortunately, we have very tight schedule, so there is no time for questions.
Sorry.
We can contact one, but we have been long We can contact you for any further question. Let me thank all the audience and all the speakers for their nice presentation and interesting work. And also let me wish the best to our chair lady because today is her main day. Okay, so let me close this very nice session. It has been a pleasure to host you, and let me thank you again in behalf of all the staff. Thank you again. Bye bye.
Thank you.
Thank you. Bye.
I remember to the share.
Bye bye.
Excuse me. I remember to the share to fill the form for evaluation of the paper.
Okay, okay. Thank you very much. Thank you.
Thank you. Bye bye.
Bye.
Oh,
Hello.
can I test the sharing?
Yes,
Okay, thank you.
you're welcome.
Tá.
Alô?
Olá, Humberto. Aqui é Ana Paula Teixeira.
Olá.
Bom dia, tudo bem?
Bom dia. Tudo. Olha, só vou testar aqui se isto
Olha, é
funciona
que eu não
bem.
sei partilhar, estou aqui a falar contigo porque não sei partilhar aqui. Estava aqui com a Ana Isabel Pereira
Ok.
e
Já-
não sei partilhar
já-
os slides.
Já te ensino. Olha, consegues ver o meu?
Consigo ver o teu, mas o meu não consigo ver.
Ok. O meu está em thank you.
Está
Ok,
em-
então
Mas
deixa
eu
lá.
não consigo ver nada. Olha o Elísio.
Hi, Lígio.
Então já estamos aqui a ver tudo. Mas olha, não consigo ver a mim, o que pode ser?
Ok. Então tenta fazer assim. Clicas aí nesse botãozinho que está à esquerda e diz Share your screen. Clicas. Eligious.
Strange language, eh?
Yeah, sorry about that.
A nice one, Lígio. A nice one.
Então e agora? Não estou a perceber o ecrã inteiro. Então vocês estão a ver alguma coisa?
E agora? Não estamos a ver nada. E agora tens de partilhar o ecrã.
Aqui diz o seu ecrã inteiro. Então, agora estou a clicar aqui e só diz para cancelar, não dá?
Não, e agora clica, já tens a tua apresentação aberta?
Já.
Hum.
Espera aí, vou fazer outra vez. A apresentação está aqui. Mas agora, é assim, eu tenho a apresentação, só que depois eu tenho que ir para o site onde tu estás que me estás aqui a aparecer de corpo inteiro, assim, na tela cheia. Agora já estou a ver-me a mim aqui, estou a ver toda a gente, estou a ver aqui a Ana Isabel, o Elígios, tu e o... e eu. Pronto, então e agora? O que é que eu vou fazer? Vou aqui para a esquerda.
Fazes share screen, share your screen.
O seu ecrã inteiro, tudo bem, mas não deixa partilhar, pá. Não deixa.
Qual é que é o browser que tu estás?
No Chrome.
Então vou fazer...
Janela de aplicações. Se calhar é assim. Não pode ser ecrã inteiro, tem que ser janela de aplicação.
Ok.
Partilhar, deixa ver. E agora, vocês estão a ver alguma coisa?
É excelente, é isso mesmo.
Ok, então pronto.
Põe só em modo. Põe no modo apresentação.
Vou fazer. Vou pôr. Pronto, assim. Mas assim deixa-me ver. Não, tenham paciência. Agora vou pôr. Senão aquilo ocupa o ecrã.
E agora fazes cancelar.
E agora não sei onde é que eu estou. Faço cancelar aonde? Lá no tal sítio. Mas ele não vai, pá. Isto como é que isto...
Já está.
Já está.
You want to
qualquer coisa, mas não
share?
foi.
Yeah, I can try. Let's see what comes out here.
Okay.
Look here.
Mas 8 minutos é muito pouco.
But okay, I'm in the next session, eh? But okay, we can do that.
Yeah, but just we have time. And Anna is the chair now, so she's not here. We can do whatever you want.
Yeah, that's right. We're free.
Yeah.
Pantalla dos. I think that's the guy. Yeah. I think this is the guy, eh?
Yep.
See it?
Hello.
Hi. But
Hello.
do you see it or not?
No. Oh, yes. We are
Okay.
seeing it, and then...
Yeah, now I also see it. Wonderful. So I already know how it works. Great. Let's get it out again, no?
Yep. Okay, fine. Good, because yesterday we have some issues with the different browsers, and some didn't work. So apparently everything is okay here.
Of course, with all the Iberians, it's working.
Yes.
No problems.
So how is everything with you guys? Healthy and safe?
Yeah, we had a nice... We were in the sea this morning. This type of
very
stuff
nice.
now, yeah. It has some advantage to do the conference at home, isn't it? You can drink your own coffee. You don't have to drink Portuguese coffee.
Yes, it's
so
true.
strong.
Anna Rocha arrived.
Hello.
Yeah, we see something. We see some hair.
I was working, okay, in another room. Room
Of
D.
course.
Okay.
You're in the castle.
Yes, I'm in the castle. I'm in my castle. I suppose you are all in your castles, yes?
No,
Mine is not so old
my
as
dear.
yours.
I'm in a dungeon.
So are you ready?
Yes.
Yeah, I should ask the questions, so I should be prepared for that, no? That's it.
Okay, it's not too much time because I was in another room, sharing another room, and it stopped now. So there's always some delay when we share. Maybe we can try to share. You can try to share. So it is in the left bottom. If
Yeah,
you
we
want
already
to-
did that.
Umberto
Okay.
already told us.
The Iberians were already doing that very
Okay.
efficiently.
Yes, he's
Where we stopped to share the screen?
I think you have to stop because in that session, one keep sharing. We saw his email and something more.
Yes.
So I don't know if
I can try to share my screen and to see. And
Yes.
Yeah, you have to click the same button again, and then it says.
Okay, I'm trying.
Try.
Okay, do you see my presentation?
Not
No,
yet.
because your camera is not on.
Oh no.
you don't have to have the camera on. Okay, when you show your presentation, you are not showing your face.
Yes.
But I need to. No, I don't need to put the camera.
No.
No, we
Okay.
can we cannot see your castle.
Okay.
But we cannot do the theater.
Do you see
Yes.
my presentation?
Yes. We are.
Okay.
No.
Okay,
Direct.
now someone else, please open. Ana Teixeira, please.
And I go
Just to see if Fernanda has to. No, you close.
I stop.
Okay, so each one can stop. How are you? Did you enjoy? Did you like the welcome reception yesterday?
Wonderful.
Very much.
What a very good Spanish wine. Right.
Hi.
Hi.
But
Hi.
it's not possible to share if the other one hasn't stopped. I can't share mine.
Yeah, the other
No.
one really has to get out, no?
I don't know.
The other one must stop sharing. Otherwise, not possible.
Be careful because yesterday some browsers don't work in sharing. You need
No,
to
but
use.
I had already tried with Umberto. I had already tried. So mine is working, but now it's not possible to share because I think someone is sharing.
No, try again.
No.
Try to click in the
Left
falar
button.
em português. Tenta clicar em cima da imagem. Quando fazes partilhar, e depois clicas em cima
That's
e
what
já.
I'm going to share.
Yeah, you
Pronto, já
are.
está.
Ok.
I'm sharing the slides?
No.
No.
Our face.
Because
Yeah. Now.
Oh yes, yes.
okay.
Very
You
clear.
you can have the slides on. Okay. Don't
Yes.
stop.
No, the problem is that I'm sharing my desktop, I think, and I was trying to share the slides but okay.
You
Now
can
I-
share your screen or you can share an application.
But
Okay.
It's better
not
the
working.
screen
The
usually.
application was not working. The application stuff was not working.
Yeah, it's better the screen.
No. Now I'm sharing you. I think.
So are you enjoying ICCSA like this? What has been your experience since yesterday?
I prefer to see you guys.
I prefer to dinner with you, really.
Yeah.
Yes.
I prefer to.
And moreover, there's no paparazzi here. So what to do?
Yeah.
Oh, the paparazzi
Carlos.
is working.
Yeah, that's finally someone is working.
Finally.
We can take a picture of our session.
We have to do that, no? Oh, then I have to put my hair.
Yes, put your hair. Frederico is the technician. Who's this one? Natalia? Hi, Natalia.
Natalia, I've seen, yeah, but just she's always silent, so we don't see her, or what?
Good day.
Hi, Natalia. Good morning.
Dobro утро.
So maybe I'll have a print screen. Okay, maybe we can start now. So this is the first edition of computational and optimization applications workshop, the first edition, the first session, sorry. And we have 4 speakers. I will say again that each speaker has 8 minutes to present and then 2 minutes for questions and answers. So we will start with the first paper that will talk about on temperature variation of the
Temperature of the fluid.
Sorry. Temperature variation of the diabetics? Food. Okay. Thank you. You can start.
I'll try to share. Let's see. I'm having problems with sharing. I don't know. Are you seeing something?
Yes.
Yes.
Okay. Something is wrong here. Well, my name is Ana Paula Teixeira, and this work is a joint work with Ana Isabel Pereira. Well, I'll begin by telling you why we were motivated to work on this topic. Diabetes is a chronic illness and affects many people. High amounts of money have been spent dealing with these diseases. For instance, in 2015,
sorry, Anna, we are hearing an echo. Are you hearing also?
No.
Yes? Tens
No,
alguma coisa?
no, I don't.
Não, mas isto está a fazer muito eco e há bocado não estava. Tu abriste mais qualquer coisa?
I don't know if its name is Fellogister.
Everything that I have, my email.
Sorry, Frederico, can you help?
Yes, I can mute the person who is unmuted. Okay. So please, everyone, close your microphone. Else, if I can do it. Okay.
Okay. Close microphone.
I have no stuff here open in my.
It's okay now. It's okay now. Thank you.
Okay. Are you seeing my slides? Can you see the slides?
Yes, we can.
I hope so, because perhaps no one can answer now. Okay.
Yes.
Well, for instance, in 2015, 1.2 trillion euros were spent with this disease, and it is expected this amount almost doubles till 2030. Additionally, diabetic foot is one of the main complications of diabetes, and between 12 and 25% of the diabetic patients develop ulcers during their life. So, in our opinion, prevention and early diagnosis of diabetic foot in diabetic patients is very important. Well, many studies showed that infrared thermography has advantages in early detection of ulcers in the plant of the foot. It is known that when an infection in the body occurs, that abnormal temperature values can be detected. So infrared thermography can help observing these changes. So in this work, we aim to analyze the foot plant temperature distribution of both diabetic and non-diabetic individuals using thermographic images. And we help to get an early and alternative diagnosis in diabetic individuals with foot pathology. And very important stuff is that it is a painless and non-invasive method. I'll talk a bit about thermography and diabetic foot. Diabetic is a chronic disease, as I said before, and it is characterized by the occurrence of abnormalities in glucose metabolism. that result in defects in insulin secretion, action, or both. And it leads to chronic hyperglycemia. And when that phenomenon occurs during a large time, it damages various tissues of the body, which leads to serious health problems. It is important to know that insulin is an hormone produced in the pancreas, and it is responsible for transporting the glucose in the blood to the cells in order to then transform it in energy. There are 3 types of diabetes. Type 1, when it's an autoimmune disease, and it's when the body damages their own cells and the pancreas is no longer able to produce insulin. Type 2, it's the most common type of diabetes, and the pancreas produces insulin, but the body gains resistance to it, so it does not do its function, and our own medication, most of times it's needed. While in type 1, you have to take insulin injections. And when hyperglycemia appears during pregnancy, we have gestational diabetes. Well, diabetes requires early diagnosis and ongoing treatment to prevent serious complications. 2 of them are nerves and blood vessel problems. Those 2 problems causes diabetic foots. When we have nerve problems, the patient gets neuropathy that affects the nerves, causing difficulty with sensations, movements, and other aspects. When blood flow problems appear, peripheral vascular disease appear, and provoking obstructive atherosclerotic of the extremities of the body. And here, with neuropathy, the person stops feeling, and then sometimes even if you have a small rock, piece of sand in your feet, it goes there, and people lose sensation, and some wounds appear. Here, with peripheral vascular disease, the extremities of the body stop being irrigated, and these 2 diseases, the main complication that appears are the ulceration. Neuropathic ulceration, the temperature when we have or almost have neuropathic ulceration rises, and if you have or are going to have ischemic ulceration, the temperature of that part of the body decreases. Well, it is known that the radiation emitted by the body can be detected by a thermographic camera, and the intensity of the radiation emitted is converted into a temperature. So, using infrared thermography, we can analyze and observe these changes, abnormal or normal, in the body. Infrared thermography has also the advantages of allowing the acquisition of a large range of pixels in a short time, and allows simultaneous monitoring of a large area, and it is a non-contact, non-invasive, non-ionizing technique. Here, in this work, we wanted to mimic the variations of the temperature in the feet. For that, we divided each feet in 3 regions, getting a total of 6 regions, and we developed a model that intended to mimic the temperature variation, in order to see how adjusted the function that we built was to the real values of the temperature in the foot. We use the minimum square method, and we try to see the value of the function in the pixel ij to the real value of the temperature. To pursue with the study, we use the normalized matrix of temperatures, and we use 2 hybrid algorithms to solve the minimum square problem. The simulating annealing and the genetic algorithm with a quasi-Newton procedure to a local search. As the results, to test this, we used 8 photos, 4 of non-diabetic individuals and another 4 of diabetical individuals. A Pentium with 2 GHz and 4 GB of RAM was used. We got the starting points generated randomly, and the code, as methods are stochastic, the code was executed 10 times, so we got 10 possible solutions for the problem. So what were our results? we realized that the generic algorithm was much faster than the simulating annealing one, and also gave us the best values of the objective function. Lower minimum, mean, and standard deviation were obtained with the generic algorithm. And we could also see that this function fit best the variation of the temperature for the diabetic images. Another study that we did was analyzing the reflection, the symmetry between the temperatures of the fish that corroborated the butterfly pattern that was described in the literature, that said that in the individuals that do not have diabetics have symmetry of the temperatures in both feet. And that's it. To conclude, we know that we are far from the final stage of the problem because the obtained values are a bit high still, but we could see that we could go with genetic algorithms, work with genetic algorithms, that simulating annealing is not an interesting algorithm to use again. We could see that this model, we are in the right direction using this model to characterize the patterns in the diabetic foot temperature, and the symmetry could also, it's good that the symmetry could also be observed with this model. That's it.
Thank you, Anna. Thank you very much.
I know that's a bit past, but we had that.
We are on time. Thank you.
Okay, thank you.
Any question or remark? No questions? Why did you use two methods? To test the methods, and then you realized that simulated annealing was not a good, you didn't get good results. And why? Do you know why?
You wanted to, you asked why did I use two methods? Is that it?
Yes, two methods to test. You are testing the methods?
Yes. No, we are testing the models, but this is a sequel. This is a work that has been done. It's not, we did not begin this work. This is another step, and some tests were done previously with other functions and with other methods. But the objective is to find the best function and trying the best methods in order to see which ones are the fastest, and so on. So the objective is to try the model, is to find the best model, and a sequel of methods have been used, and this time we decided to use both of these, but not of course that now I know that I should go with the genetic and with someone else, some other else, because simulating annealing is not in internet, it's much slower. So but the objective is that, not the method.
Okay, thank you. Any more question or remark?
Yeah, at least I should make a remark. No, this is my work. So what I like about the approach is that nowadays people would certainly use neural networks to do your analysis. So what I like about your work is that you are looking for several models instead of what people are doing nowadays, is just throwing it into a neural network. That was my remark.
Okay.
Okay, thank you. Thank you. Let's go to the next speaker. I think it is Angela. Please stop your share. Yes.
I think I stopped.
Now the next speaker, it's Angela. She will present the impact of the increase in electric vehicles on energy consumption and GHG emissions in Portugal. You can start sharing, please. Angela is not here.
We can't listen you.
maybe go to the next speaker. Angela, you can open your microphone, please. Oh, that's open.
I see her microphone is open, but we can't listen her.
Okay, Angela, we are not listening to you.
Try to refresh the browser, else you should try to use a different browser. And check on the top right of the browser if you allow.
I'm listening. I'm
You are
listening, Angela. Yes, I'm listening. Yes.
Angela, we are not listening, Angela.
But
we are all listening.
Me, Anna, I'm listening.
You are listening, Angela?
Yes.
And the others?
No, Angela, try to refresh your browser. Maybe it's a problem.
Are you hearing us, Angela? Refresh your browser, please.
Angela is speaking. I translate. Very loud.
Can you ask to Angela if she listens us?
Sorry,
she wrote in the chat.
She was Angela, try the chat.
Very loud. Try to refresh the browser, okay?
Okay.
Maybe we can go to the next speaker. Then we go to Angela. Now, Fernanda Costa, please. The penalty-based heuristic direct method for constrained global optimization. Paula?
Yes.
We are going to the next speaker. Then we go to Angela, okay?
Okay. Good morning to everyone.
Good morning. So, just a moment now, Fernanda. Thank you. Fernanda, we are not listening to you. Are you talking?
I am here again. Can you listen to me right now?
Okay, maybe we can go to Angela because
I can wait for the following section. There's no problem. Are you listening to me right now?
Yes.
Yep.
Oh, thanks.
Yes.
Yes.
I do my presentation or Angela do presentation?
If you don't mind, we go to Angela, okay?
Okay.
Thank you. Angela, please share your application. Okay. Thank you. We can start. So Angela will talk about the impact of the increase. Okay, I have already said. Thank you.
Okay, thank you for the introduction, and I'm sorry for the problems before. I will start with a preview of the presentation. After the motivation and the objectives of this work, it will be introduced the methodological approach and some details of the case study, followed by the main results and finally the conclusions. In terms of the motivation of this work, in mainland Portugal in 2017, 24.3% of greenhouse gas emissions came from the transport sector, being the second sector with the higher contribution to the total emissions. The final energy consumption in road transportation was about 37% of the energy dependency, was almost 80%. On the other hand, the National Energy and Climate Plan for 2030 establishes a reduction of 17% of greenhouse gas emissions compared with the 2005 levels, and a reduction of energy import dependency to 65% of the total energy consumption. These targets require, among other policies, the penetration of efficient transportation technologies. So this work aims to analyze and forecast the impacts on energy consumption and greenhouse gas emissions following the increase in the penetration of plug-in, hybrid and electric vehicles in the Portuguese mobility system, replacing the internal combustion engines-based vehicles. The study considers 5 different scenarios with different levels of PHEV penetration in light fleet, including passenger and commercial vehicles. Data on electrical propulsion-based vehicles is available only from 2011, so the time frame comprises the years from 2011 till 2030. The model developed to analyze the energy consumption in the transport sector corresponds to a hybrid model that combines bottom-up and top-down approaches. The projection of energy consumption is found from disaggregated data according with the requirements of the bottom-up approach, while the fleet forecast is implemented exogenously, increasing the robustness of the model and gathering a top-down characteristic. In terms of the forecast of greenhouse gas emissions, it follows a bottom-up approach and it consolidates the recommendations of the Intergovernmental Panel on Climate Change. These models are implemented in the long-range energy alternative planning software from the Stockholm Environment Institute, which is an integrated modeling tool able to assist in energy policy analysis, and it includes a technological and environmental database considering, for instance, default emissions factors and consumption's propulsion type and based on fuel types. The energy consumption in the transport sector is defined based on the product of the related variables, stock of vehicles, annual vehicle mileage, and fuel economy. The stock of vehicles relates with the sales and the survival index. The sales forecast is obtained through a regression model considering the gross domestic product, and the survival was estimated according to the Gompertz curve and represents the percentage of vehicles in use related to their vintage, that is to say, the year in which the vehicle starts its use. The annual vehicle mileage is understood as the estimated distance traveled times a degradation rate, which in turn is a function of the vehicle age. And the fuel economy is directly linked with the type of fuel used, if gasoline, diesel, LPG, or electricity. With regard to the greenhouse gas emissions, they are found using the emission factor in tons of carbon dioxide equivalent per terajoule times the activity, which translates the amount of energy consumed function of the type of vehicle and the mileage. The case study considers 2011 as the base year, and the forecast is made till 2030. And in the base year, the vehicle fleet comprises 97.5%, of light vehicles, and this category is most likely subjected to a technological change. Doing so, the study is limited to light vehicles, including passenger and the commercial ones. The scenarios under analysis are the base scenario that is characterized by a rate of sales per vehicle propulsion type constant and equal to the base year. The other scenarios consider a penetration of plug-in, hybrid and electrical vehicles in detriment of sales of internal combustion engines-based vehicles with a rate of 10, 30, 60 and 100%. Under these scenarios, the projection of the PHEV fleet is as shown in this picture. The results in terms of total energy consumption forecast are given here. The energy consumption rate related to the base scenario decreases with increasing PHEV penetration, and the consumption increases for base 10% and 30% scenarios and is almost constant for the 60% scenario and decreases for 100% scenario. These results may be explained due to the higher efficiency of electric propulsion-based vehicles. In order to preview the impact the fleet change may have in the electrical grid infrastructure, the forecasting of the electric energy consumption for the different scenarios under consideration is also performed. The output shows that electric energy consumption increases with increasing PHEV penetration, from which electric energy demand and impact in electrical grid infrastructure should be considered. Finally, greenhouse gas emissions forecast follows the behavior of the total energy consumption, with the emissions decreasing below 2017 levels for the 60% and the 100% scenarios. So the main conclusions are that the increment of PHEV vehicles in the light vehicle fleet translates in a decrease of total energy consumption for 6% and 100% scenarios due to the higher technological efficiency of PHEV fleet, which contributes to the reduction of the national imported energy dependency. There is also a shift in the energy source, given that the total energy consumption reduces, but the electric energy demand increases. The emissions follow the total energy consumption forecast, decreasing with increasing PHEV penetration, and emissions decrease below 2017 levels for 60 and 100% scenarios. Future work should consider the impact in electrical grid infrastructure and should also apply this analysis to PHEV penetration in the heavy fleet. So thank you for your attention.
Thank you, Angela. I'm asking again to stop your microphone, please, if you are not talking. Any question or remark?
Yes, Anna, I would like to make a remark and a couple of remarks and not a question. First of all, congratulations for this presentation and for your work. I was lucky enough to read your paper and I found it very nice. It's an hot topic. Green stuff is in the order of the day. And I think the paper is very well suited for this workshop. The remark is the removing of the heavy vehicles or trucks. And even knowing that they are only a small percentage of the vehicles in Portugal, compared to cars or light vehicles, I'm sure they pollute much more. So, and you refer that in future work, you will assess also the heavy vehicles, and I think it should be interesting to see that trade-off between the percentage of heavy vehicles, but the amount they pollute. Thank you.
Thank you very much for your comment. I just want to remark that we excluded the heavy fleet of this study, but it's not very likely that the PHEV fleet will be a technological option in this kind of fleet. That's one reason, with also the small percentage in the overall fleet. That's why we did not consider it here, but in a future work it should be also included. Yes. Thank you very much.
Very well.
Thank you. Any more remarks?
Can I say
Questions?
something?
Yes, you have an electric vehicle.
That's right. For 6 years, I'm the guy in the town who has the electric car. So there are some non-surprising things in the study of Angela. The fact that energy consumption goes down and that the world is better is the non-surprising part. But the surprising part, perhaps, is in your analysis, is that we require like 60% or 100% changes into electric penetration in order to be able to reduce the energy. This is quite the impact. So that's what I learned from your study. That's very nice. On the other hand, it's very difficult to make predictions anyway due to shifts that are taking place all the time. And one of your things in the analysis was also that you said, okay, we need more infrastructure for electricity. So what happened in Spain, which probably did not happen in Portugal, is that we have now a better government, Anna. So what happens is that now I have my solar panels since 2 months, and now I'm charging my electric car with my own solar panels, okay? So that development does not require a more heavy infrastructure in the transportation of electricity. And that may be very different in Portugal, because in Portugal was much earlier in investing in solar panels and in windmills, let's say it like that. So it's also very difficult in a global model to make a good prediction. So that's what I wanted to remark.
Yes, thank you. It's very difficult to make this kind of predictions reliable. That's the main problem. Also the fact of the data is not very consistent, and the prediction of the data also implies some uncertainty in the study. Regarding the impact on the infrastructure, this is not have been done yet in this study. Perhaps in the future approach to this work will consider this. But thank you very much for your remark. Thank you.
Thank you. We have to going on. Thank you, Angela. Now, Fernanda, you can start sharing your presentation, please. You will talk about the penalty-based heuristic direct method for solving constrained global optimization problems. So you can start. Thank you.
Do you see my presentation?
Yes.
Okay. Thank you.
If you want, you can put in full window. Control L. Okay, thank you.
Okay. Thank you. I will present a penalty-based heuristic direct method for constrained global optimization. This is a joint work with my colleagues Ana Maria Rocha and Edith Fernandes from Algorithm Center of University of Minho. This is the outline of my talk. First, I will present a brief introduction and some ideas of direct method. Then I will present the heuristic direct method based on penalties. And finally, I will show some numerical experiments and conclusions. The aim of this work is to extend the heuristic direct method presented in 8 to solve non-smooth and non-convex constrained global optimization problems. Main contribution of this work, the heuristic direct method is extended to solve CGO problems using an auxiliary penalty function. The auxiliary function proposed in 15 is redefined to transform the CGO problem into a bound constrained global optimization one. The CGO problem has this form here, where the objective function and the constraint functions are nonlinear continuous functions. the omega is the set defined by the bound constraints on decision variables, and F is the feasible region of this problem. Since convexity is not assumed, many local minima may exist in the feasible region of the problem. To solve non-smooth CGO problems, derivative-free, deterministic, and stochastic methods are the most appropriated. Using deterministic methods, the convergence to a global optimal solution can be guaranteed. On the other hand, stochastic methods are not guaranteed to find a global solution, although they are often able to find very good solutions after a large number of the steps. For non-smooth BCGO problems, the direct method has proven to be quite effective in converging to the global solution while avoiding to be trapped in a local one. The most popular methods to solve CGO problems are the penalty methods, which combine the objective function with a penalty term that aims to penalize constraint violations. Now I'm going to give some ideas about direct method. Direct method for BCGO problems assumes that f, the objective function, is continuous, and it generates from the search space omega thinner and thinner partitions of hyperrectangles. This algorithm organizes the hyperrectangles by groups of the same size, and it considers in each dividing in each group the hyperrectangle that have the lowest objective function value. These hyperrectangles are called candidate hyperrectangles. Direct algorithms search locally and globally the search space omega by dividing some of the candidate hyperrectangles, which are designated by potentially optimal hyperrectangles. Now I'm going to briefly give some ideas about heuristic direct method presented in 8. To improve the efficiency of direct method, heuristic is incorporated in the direct method to potentiate the exploration of the most promising region of the search space. And a two-phase strategy was implemented to cyclically encourage the global search in the first phase and enhance the local search in the second phase. The proposed heuristic divides the region of the candidate hyperrectangles into 3 subregions. To randomly select a specific number of hyperrectangles from each one of these subregions, differently if is for the first phase and in second phase. The two-phase strategy works as this. The first phase aims to reinforce the global search of direct by avoiding the selection of hyperrectangles that were mostly divided and selecting all the hyperrectangles with largest sizes. And this phase runs for a Gmax of iterations. The second phase is the opposite, aims to improve the local search of direct by avoiding the selection of the hyperrectangles with the largest size and selecting all the hyperrectangles with smallest sizes. And this phase runs for Lmax of iterations. The set of potentially optimal hyperrectangles are then identified from the select hyperrectangles in these phases. Now I'm going to give a brief description of the penalty auxiliary function. We use this auxiliary function proposed in this paper here that penalize any deviation of the function value at the center C of a hyperrectangle above the optimum value known. Here, mu are positive weighting parameters, and if all hyperrectangles have feasible center points, the second term here is 0. If the hyperrectangle has a infeasible center point C, this second term here is positive. And this term here only counts for the case where the function value at the center C of a hyperrectangle is above the optimum value. Since the optimum value is unknown in general, but we know that satisfy this condition here, where f min is the best function value found so far among all feasible center points, we redefine the following variant of the auxiliary function as this. So the penalty-based heuristic direct algorithm finds a global minimum solution of this problem here. In our work, we consider the penalty parameter fixed all over the iterative process. So now I'm going to show you some numerical experiments. The penalty-based heuristic direct algorithm stops when we find a point that satisfies this condition here. This means that it is a feasible point, and this p-error value given by this expression is lesser than 10 to the minus 4, or if the number of function evaluation exceeds this quantity here. The tables report average values over 5 independent runs of our algorithm, and our results are compared to those in these 5 papers. First, we compare the performance of the algorithm with the penalty auxiliary function, penalty 2, and with the L1 penalty, with 4 values of penalty parameter, when solving the problems 1 and 2. Here are the results with the problem 1. From this result here, we can conclude that our algorithm with the penalty 2 gives significantly better results than with penalty 1 when solving this problem 1. Here are the results when solving the problem 2, and similarly, we conclude that the penalty 2, the penalty auxiliary function, performs better than compared to the L1.
Another 2 minutes, please.
Okay. Our algorithm with penalty L1 works better. We need this result works better with large values of the weighting parameter, while the performance of the algorithm with penalty 2 is not too much affected by the values of mu. Here, your comparative results, our results are compared to those in these 3 papers, 8, 14, and 17, when solving these problems 1 and 2. And from this result, this comparison here, we see that a slight gain in efficiency of our algorithm is detected comparatively to the other algorithms in these 3 papers. So here, compares result when solving the problem 3. And from this table here, we see that the algorithm reports a considerable sensitivity to select mu value with a better performance achieved when small values are used, and the algorithm competes favorably with other algorithms present in these 3 papers. So, conclusion of this work, an extension of the heuristic direct method present in 8 to solve nonlinear CGO problems is proposed. The proposed extensions transform the CGO problem into a BC1 using a penalty strategy based on the penalty auxiliary function 2. And the preliminary numerical experiment shows that the proposed algorithm competing favorably with other available direct type algorithms. Thank you for your attention.
Thank you, Fernanda. Nice presentation. Nice ideas. I want to ask you for questions or remarks, please. No one? Are you listening? Because I know that someone was having some problems. Any question? Okay, Fernanda, you can stop your sharing and we go to the last speaker of this session, Humberto. You can start sharing, please.
All right.
Okay. He will talk about the comparison of different strategies for ARC therapy optimization.
Okay, thank you for the introduction. So I will try to keep within 10 minutes. In this work, we compare different strategies for ARC therapy optimization. The outline is the following. I will briefly describe the problem. Then I'll describe the optimization strategies, and then I will present the results and the conclusions. So briefly describing what is intensity modulated radiation therapy. It's a modern type of radiation therapy, and the goal is to kill the cancer cells while simultaneously sparing the surrounding organs or tissues. The radiation is delivered with the patient immobilized on a couch that can rotate, and the radiation is generated by a linear accelerator mounted on a gantry that rotates around the patient. The rotation of both the couch and the gantry allows irradiation from almost any direction around the patient. This year, unfortunately, I cannot show a video. It's the first time in many years, but we have no time, so I have a picture. And this figure illustrates the irradiation of a patient that lays in the treatment table or couch. And the irradiation is delivered while the linear accelerator is rotating around the patient with the beam always on, or radiation can be delivered only at certain beam directions. So basically, we have two different types of treatment techniques, a static one, also known as step and shoot, and a rotational one that has the beam always on. In this study, we will focus on ARC therapy. The latest generation of linear accelerators allows simultaneous movement of both the couch and the gantry, provided that collisions are avoided. This work focuses on the optimization of these ARC trajectories. The strategy we propose for optimization of the ARC trajectory is illustrated by considering a head and neck cancer case already treated at IPO Coimbra. And here in this table, we have the doses prescribed to the tumor volumes and the tolerance dose for the organs at risk considered for this case. We will consider a two-step optimization approach in order to identify the best possible directions where the non-coplanar arc should path. We start by calculating a set of non-coplanar beam directions using one of the beam angle optimization algorithms already proposed by us. Then, and it's not new, this first step, then in a second step, anchored in the beam directions calculated in the first step, we will compute more anchor points, and these anchor points will define the non-coplanar arc trajectory, and this computation is iterative. And we will consider the same dosimetric criteria used for the non-coplanar beam angle optimization, which is the optimal value of yet another problem, which is the fluence map optimization problem that typically I describe, but I don't have time here. And it's simply the problem of finding the beam dose intensities. Here, one of the novelties of this work is also the computation of this fluence map optimization problem. In order to make this more reliable, we use a direct optimization approach. We have to highlight that the beam angle optimization problem of the first step is very difficult, is the core of our work, and it's very time consuming. The main goal of this work is to consider different number of beam directions in the first step and then compare the proposed approach in order to assess the trade-offs between treatment quality and computational time required to obtain a non-coplanar rotational plan. So, in the first step, we consider a recently proposed strategy to explore the continuous search space of the beam angle optimization problem. In 10 minutes, I don't have time to detail this, but you can check the paper or can ask questions in the synchronous platform. In the second step, we will consider a discretization of all possible beams as illustrated in 2D in the left-hand side or in 3D in the right-hand side. The black beams are coplanar beams, while the blue beams are non-coplanar. The main goal of this second step is to connect the non-coplanar points that were obtained in the first step using the beam angle optimization approach. I will not fully describe the algorithm, but the algorithm has the two steps. In the initial step, or in the initialization, we use the beam angle optimization approach to compute a set of non-coplanar beam irradiation directions. Then, anchored in these directions, in an iterative way, we compute further beam directions or points until we obtain 21 points. Why 21 points? Because that's what everybody else do. These 21 anchor beams or directions will define the arc trajectory. I will illustrate the idea of the iterative algorithm resorting to our head and neck cancer example. In the left-hand side, we have the non-coplanar solution obtained in the end of the first step when we consider 5 beam directions, and it corresponds to the red points. The green points are the feasible points to add iteratively when moving from one red point to another from left to right. We test iteratively each of the green points of the largest set of green points, it's one strategy, one at a time by adding them to the red points and computing the best plan with 6 beam irradiation directions. On the right-hand side, we have represented the best point found in red, and we remove the green points that become unfeasible and continue to the next iteration to find the 7th red point and so on until we obtain the 21 red points. In our tests, we consider 5, 7, 9, 11, and 21 points in the first step. And in this table, we have the results in terms of optimal value of the fluence map optimization problem for step and shoot, IMRT, and for the goal of this paper for rotational therapy, VMAT. We can see that by increasing the number of beams in the first step, the optimal fluence map optimization value improves in terms of IMRT, step and shoot, but in terms of what we want, VMAT, that is adding extra anchor points, all plans obtain similar values of final objective function. So there are no differences. We also display the computational time, and the differences are here. And we can see that considering less beams in the first step, in particular if we consider 5 beams, it takes much less time than optimizing more beams in the first step. As medical physicists do not care about objective function values, but rather other clinical metrics, we compare the best plan obtained with our strategy, both in terms of objective function value and computational time, which is VMAT5, with the best step and shoot strategy, IMRT11, and the typical rotational plan used in clinical practice, VMAT0. 0 means that the couch is fixed at 0 degrees. In this figure, we present the different trajectories or beam directions for each of the plans. The measures typically observed by medical physicists are tumor coverage metrics, that is the amount of dose received by tumors. The tumor coverage is very similar for all plans, and the difference occurs in organ sparing, and that's what we have here, the amount of dose received by the surrounding organs. In this table, we can observe that the treatment plan resulting from our strategy outperformed the other plans in terms of organ sparing. This is also illustrated in this figure that resumes the numbers of the previous table. The lower the point, the best the plan. So, and speeding up, in conclusion, and I will not read all this, the strategy is good, and it's more efficient when we consider less beams, and we should perform further tests because we only test these in one head and neck cancer case, not only for more cases, but also for different tumor sites. Thank you.
Thank you very much. Very nice presentation without the video. Okay, next year we will see a video if possible.
We hope so.
Any question or any remark? No one's? We still have time. So your work was based to test the number of beams that you are using, 5, 7, 11, and then you concluded that the best results. Is that?
Well, we have a two-step strategy for this. Is a different type of treatment, which is rotational, which is different from what we used to present, which is step and shoot. And for step and shoot, actually increasing the number of beams improves the treatment quality in terms of function value. But actually medical physicists do not look at function values because they only care about their clinical measures, but they are somehow related. But for rotational plans, that is the beam is always on while rotating around the patient, it's rather irrelevant if we consider less beams initially or more beams. The difference is on the computational time. If we consider less beams, we obtain similar plans, but in much less time. So that was the main finding of this work.
And regarding the medicines, they were surprised with that conclusion or not?
I should say I would like to say they were surprised, but honestly they do not care. they only want the best plan for free meaning that it's automated. So our next move is to automate this in order to deliver them this for free. So they don't have any work doing this optimization part that in clinical practice most of the time is still step and trial and error. Yeah. So they want this for free. They don't care if it takes much or less time.
Okay, thank you. You should keep working.
Okay, thanks a lot. And good luck.
You. Any remark or any question? No? So thank you all. We will have the next session of this workshop on the afternoon at 4:30 for Italian time and Spanish time, but Portuguese time is 3:30. Okay, so see you soon later. Okay, now have a good lunch.
Have a good lunch. See you later.
See you later.
See you later.
Bye bye. See you later.
Thank you. Bye.
Bye bye.
Thank you.
Estava ali o nosso fotógrafo.
É o paparazzi, pá.
Então, onde é que é o passeio este ano?
Olha, o passeio é muito giro assim na praia. É um passeio de barco, depois tem uma parte em que vamos a pé, assim tipo uma floresta, muito giro.
Também vamos montar golfinhos.
Pois, não sei, vamos ver, tudo depende do que aquilo de dia para dia aparece uma coisa diferente. Pronto. E espero que estejam a gostar dos coffee breaks e dos almoços também. O welcome de ontem, o vinho era muito seco o vinho de ontem. Era muito seco.
Então os outros já saíram?
Pronto.
Aqui só
acho que sim.
A Sandra.
Acho que sim. Sabes que está tudo na hora do almoço. Não sei quem é aqui um fellow que não assina.
Se calhar sou eu, a Filomena.
Ah, Filomena. Olá, por acaso começas por F, vá lá.
Fisioterapia,